Hey guys, we are still on Unit 5. Today we're talking about some atomic math and talking more about ions and isotopes. Hopefully most of today is just review for you from last year. So let's review what you guys should know very well by now. Our three subatomic particles for the atom are going to be neutrons, protons, and electrons. There's a picture there at the bottom that shows the relative size of those. Protons and neutrons are about the same, and then obviously electrons are super tiny. Remember that we have protons and neutrons in the nucleus with the electrons orbiting on the outside. Also remember this picture that we talked about a few days ago. An atomic model the size of Busch Stadium and the parking lot would contain a pea-sized nucleus. That nucleus would account for 95.95% of the atom's mass. The P at the pitcher's mound would be the nucleus, and if there was an ant crawling outside in the parking lot, that would be an electron. So this is just kind of trying to put into perspective how small an atom is and how small the nucleus is and how extremely tiny the electron is. So remember that an atom is mostly empty space. Electrons, again, those were discovered by J.J. Thomson and Millikan. They're located around the nucleus, kind of orbiting the nucleus in a wave type way. So the charge is going to be -1. Again, it occupies the majority of space in an atom, but it has pretty much no mass. It's super tiny. Next, we have protons. This is discovered by Goldstein in 1886. Again, located in the nucleus, super tiny. It's about 1 AMU, or a mass of 1. Its charge is positive, so we say it's a +1 charge. Next, I have neutrons, discovered by James Chadwick in 1932. Again, located in the nucleus. There's the mass for you. It's pretty close to, we just call it 1 AMU, or 1. The charge is neutral, so 0. Okay, what are nuclear symbols? This you hopefully saw last year in chemistry. The examples down there in that right corner. X would be the element symbol. Z would be the mass number, which if you remember 8-man, mass number is protons plus neutrons. And we can kind of manipulate that equation to solve for what we want. A is atomic number, which is also equal to the protons. And then obviously the charge can be up there on the right side. Don't forget that the number of protons is what determines what element it is. Okay, we can also say that neutrons is your mass number minus the atomic number. Okay, so again, atomic number is going to be equal to your protons. On this type of symbol, it's that bottom number. So in this case, 7 and 6. It gives the atom its identity. If there's 6 protons in the nucleus, that's a carbon atom. If there's 7 protons in the nucleus, that's a nitrogen atom. So just pay attention to that bottom number on these symbols. That's going to be telling you what element it is. Next, we have the mass number. This is equal to the number of protons plus the neutrons. It's always going to be a whole number. It will never be a decimal number, but a lot of times it is pretty close to that decimal number that's on the periodic table. Next, we have, and that's also the number on the top of those symbols. This is going to tell you the mass of the atom. Not all atoms of the same element will weigh the same amount. So this mass number is really important. 2 atoms of carbon are shown down here below. One of them only weighs 12 and one weighs 14. So those 12 and 14, that's telling us the mass. It's still carbon because it has 6 protons, but they're going to have different mass because they have a different number of neutrons. So protons will be the same, neutrons will be different. If we want to figure out how many neutrons each one has, we can use this equation. Your mass number minus the atomic number, which is also just protons. Okay. So let's practice that. An atom containing 18 electrons, 16 protons, and 17 neutrons. We need to figure out what element it is, and we need to draw its symbol. So if it has 16 protons, that also tells us the atomic number, which is 16, which tells us the element is sulfur. Okay? We also can figure out the number of electrons. There's 2 more electrons than protons in this case because they gave us that number. If there's 2 more electrons than protons, that's going to tell us the charge. There's more electrons than there are protons, so the charge is -2. We can also find that by just adding up the protons and the neutrons, which is the mass number. Okay, what is an isotope? Atoms of the same element that weigh different amounts. So here's this picture of carbon again at the bottom. It's the same element, but they weigh different amounts. We have 12 and we have 14. These are both isotopes of carbon. What is an ion? If the number of protons equals the number of electrons, then that atom is not charged. It's neutral. Okay? The charge is going to be your protons minus your electrons. So if there's more protons than electrons, the atom is positive, which is called a cation. Remember, cats have paws. Paws sounds like positive. That's a good way to remember that. If the number of electrons is greater than the protons, then it's a negatively charged atom, and that's called an anion. All elements are neutral and not charged. An element has to react in order to have a charge. A charged atom is going to be called an ion. So let's practice some of this stuff that we talked about today. First, we have our nuclear symbol. It says, write the nuclear symbol for an atom containing 18 electrons, 16 protons, and 17 neutrons. So right away, I know the atomic number is 16 because I have 16 protons. That tells me my element is sulfur. It also tells us the number of electrons, so we can figure out the charge. There's 2 more electrons than protons, so my charge is just -2. Next, we need to figure out the mass number, so we're going to add our protons and neutrons together, so 16 plus 17. When I do that, this is the symbol that I get. So I have mass number on top, protons on the bottom, and then my charge. Okay, isotopes. Which of the following represents isotopes of the same element? So here's all my isotopes. I need to figure out what elements they represent. Look at the atomic numbers. So the numbers on the bottom, anything that has the same atomic number is the same element. Okay? So these 2 isotopes both have 7 protons. So they are both nitrogen. They're isotopes of nitrogen. They just have a different mass. These 2 numbers both have 6 protons. So they are carbon. Again, same number of protons means same element, but they do have a different mass. Next one, which of the following represents ions? So I have 3 numbers here, or 3 symbols here. That little square is supposed to be a plus sign. So if I'm trying to figure out ions, all I have to do is look for my charged atoms. So if I have a +1 on the left and a -1 on the right, both of those are going to be ions. So I'm just going to read through this. A charged atom is known as an ion. Anything with a charge is going to be an ion. Positives are cations, negatives are anions. Look for any atom with a charge in that upper right-hand corner. If it has a charge, it's going to be an ion. Charge means the atom has reacted and now has either more electrons than protons or it has less electrons than protons. If it's negative, that means it gained electrons because electrons are negative. If it's positive, that means it lost electrons. So this picture in the bottom shows me different ways that those can be written. All of them just mean that it has a +2 charge, which means it has 2 more electrons than it has protons. Okay guys, that is it for today. Hopefully that was really more of a review than anything else. You have a worksheet, and then I want you to spend the rest of your time today catching up on any missing work.